Hello everyone. Today's lesson is 6.2. It is my last day in sunny Arizona, so I thought I would share the sunlight with you for this next lesson. It is 6.2 substitution. All right, let's go ahead and get started. Previous objective was to solve systems of equations by graphing, and the two objectives for today are to solve systems of equations by using substitution and solving real-world problems involving systems of equations by using substitution. Now, I don't want you to write down the actual vocab word for substitution, but rather I want you to write down the steps in order to solve by substitution. So step number one, when necessary, we are going to solve we are going to solve for at least one variable. Step number two is we're going to substitute that equation into the second equation and solve for either x or y. And then step number three is to solve for x or y for that last equation. And this will all make sense once we start going, but make sure you have the rules for substitution down. All right, so example number one is to solve a system by substitution. And for example number one, they make it very easy for you by giving you one equation that's set equal to x or y. In this case, it's y equals 2x. So what I'm going to do is wherever I see a y in my second equation, I'm going to substitute 2x. So I have 3x plus 4, and instead of writing y, I'm going to substitute it for 2x, and that equals 11. So this gives me 3x, distributive property gives me 8x equals 11. And I get 11x equals 11, divide both sides by 11, and I get x to equal 1. Now what I'm going to do is you're going to substitute x equals 1 in for either equation and solve for y. I'm going to do the first equation because that's the easiest, and it's 2 times 1, so y equals 2. So your answer on your paper, they're looking for a coordinate, which would be 1, 2. And what that means is, just like we did in example number one, we went through the different examples on how two lines will intersect. They're either going to intersect at one point, at all points, or at no points. And for example number two, by substitution, a majority of your problems are going to intersect at one point. Graphing is doable, but in most cases we don't want to sit and have to graph and put them into slope-intercept form all the time, so we can solve by substitution. These two lines right here would intersect at the point 1, 2. They would be consistent and independent events. All right, let's do the next example. So again, they give you y equals negative 4x plus 12. So wherever I see a y in the second equation, I'm going to substitute. So 2x plus, instead of the y, I'm going to put negative 4x plus 12. And I'm going to set it equal to 2. So again, it's 2x plus y, and instead of y, I'm substituting negative 4x plus 12. Now I'm going to solve it. So 2x and negative 4x gives me negative 2x plus 12 equals 2. Subtract 12 from both sides. Negative 2x equals negative 10. X equals 5. Now again, you can stick it into either equation to solve. I'll put it back up into the first equation. So y equals negative 4 times 5, because that's what my x equals, plus 12. So y equals negative 20 plus 12, which is negative 8. So again, your answer on your paper would be your coordinate 5, negative 8. Again, we are substituting to figure out the system of where these two equations meet. All right, example number two is to solve and then substitute. So as you can see here, neither equation is set equal to x or y. But I notice that I have one equation that has x all by itself. So what I'm going to do is I'm going to add 2y to both sides. And I get x equals 2y minus 3. So this equation here is x equals 2y minus 3. It is the exact same line. We haven't done anything to it. We've just rearranged to solve it for x. So I have this equation here that I'm going to use and this second equation here. And I'm going to follow the same rules as I did in example number 1. So example 2 is just adding that extra step to solve one of them for x or y. So wherever I see an x in this equation, I'm going to substitute 2y minus 3. So I have 3, I'm going to substitute 2y minus 3 plus 5y equals 24. So I get 6y minus 9 plus 5y's equals 24, which gives me 11y minus 9 equals 24. Add 9 to both sides, and you get 11y to equal 33. So y equals 3. So that's my y coordinate. And now my next step is to go back and substitute and figure out what my x equals. I'm going to use this equation right here. So x equals 2 times 3, because that's what my y equaled, minus 3. So x equals 6 minus 3, so my x equals 3. So your coordinate, these two lines intersect at 3, 3. All right, hopefully this is making sense, then it'll make more sense the more practice that you have. This is the multiple choice question on the Google form. Notice that it's example 2, meaning that neither equation is set equal to x or y. So that's your first step, is to set one of these equations equal to x or y, substitute it in and solve for x or y, and then do it again to solve for the other variable. All right, example number 3 is no solution or infinitely many solutions. Just like we did it in 6.1, if it is infinitely many solutions, that means that these equations are going to be the exact same line. No solutions means that they're never going to intersect. So to find a solution when two lines never intersect, our answer ends up being no solution. So we look at these two equations, and the first thing would be to set one equation to set it equal to either x or y. I'm going to solve the second equation for y. So I get y equals negative 2 minus x. So now I'm going to substitute that in for the first equation. And what you see is that when I solve that, 2x and 2x cancel out, and I'm left with negative 4 equals 8. Well, when two numbers don't equal each other, our answer is false. There's no solution, and our answer would be no solution. Now the opposite to this is that when I solve it, I get 8 to equal 8, and if they equal the exact same number, that would mean that they are infinite solutions. So we have two examples here. If they do not equal the same thing, impossible, it's no solution. If they equal the same exact number, that means that it's infinite solutions, or it's the exact same line essentially. So that is it for the 6.2 video. Again, it's going to take some practice for you to get used to substituting the variables in and solving for x and y. And again, all of your answers are going to be coordinates unless it's no solution or infinite solution. All right, and your open-ended question for 6.2 video is to use substitution to solve the systems of equations. So because this is an example number 3, you can assume that it's either going to be no solution or infinitely many solutions. So go ahead, take your time, solve this substitution problem, and tell me what you get for a solution. Thanks, and we will see you tomorrow. So if you have any questions, feel free to write them in the Google form. Otherwise, I look forward to reviewing the lesson with you tomorrow.